Okay, so if you'll pass up last week's work on 5.5, 5.6, if you still have them, I need all those. Do anybody have any? There was one class I just didn't take up the 5.5, so I guess I went in this one. All right, and 5.6 I took up at the end of the hour because we did it together. Now we're going to move on to something called the binomial expansion. And instead of doing a bell activity, we're going to watch a Khan Academy video. All right, so before we start also, I'm going to pass out something called Pascal's triangle. Okay, Pascal's triangle, if you notice, when you get the sheet, if you will notice that you need something? What? Okay. So if you notice when you get the sheet, it starts with a 1 up at the top. I should probably point with this. It starts with a 1, and then the next row is a 1. I'm sorry, it starts with row 0, and a 1 is in it. And then the next row, row 1, has 1s. If you notice, the outside of these, both edges are all 1s. Okay, so for Pascal's triangle, that's how they construct it. On the outsides, it's all 1. But when you get on the inside, say for example, there's the outside of 1, and then the next number is 2, and then a 1. For the third row, you've got a 1, a 3, and a 1. Well, if you notice, there really is a way how they calculate these. So if you notice that 1 plus 1 is 2. See that? And then you start the next row with a 1, and then 1 plus 2 is 3, 2 plus 1 is 3, and then the outside row is 1. And go to the next row. Start with a 1, 3 plus 1 is 4, 3 plus 3 is 6, 3 plus 1 is 4. And outside row is 1. Fifth row, 1. The next 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then an outside row. So you see how this is constructed. Oops, I didn't mean to do that. So let me delete those. I can. And get it clean again. All right, so I'm going to pass one of these out to everybody while this video is going. This video is about using Pascal's triangle to expand binomials. And when I talk about expanding binomials, I'm talking about what if I have a binomial like x plus 3, and I want to expand it to the 5th power. Well, when it was to the 2nd power, that was easy, right? We would just FOIL it out. X plus 3 times x plus 3. And then we learned a formula. It's a squared plus 2ab plus b squared. Well, once you memorize the formula, or you find a formula, it becomes quite easy. Well, what if I tell you we can find a formula for expanding these things to the 5th, 23rd, whatever power? Okay? If we didn't have a formula, we would have to take x plus 3 squared, and whatever that is, and then we're going to have to multiply that answer, that trinomial, times x plus 3. And then we get 4 terms that we're going to have to multiply by x plus 3. And you notice this would be very tedious and very, very, very long. It would take a long time to get to that answer. And there were so many small calculations and combining like terms that it's very likely we would make an error. So to cut down the errors and cut down our time, to make it much more efficient to calculate, they've used something called the Binomial Theorem and Pascal's triangle to find a little pattern, a little algorithm to solve these. And that's what this video is going to introduce. At the point where he starts the video, he's already talked about the Binomial Theorem. So let's begin. Make sure to hit play on yours and just let it play out if you're not with me.
We were able to apply the binomial theorem in order to figure out what a plus b to the fourth power is in order to expand this out, and we did it. And it was a little bit tedious, but hopefully you appreciate it. It would have been useful if we did even a higher power, a plus b to the seventh power, a plus b to the eighth power. But what I want to do in this video is show you that there's another way of thinking about it, and this would be using Pascal's triangle. And if we have time, we'll also think about why these two ideas are so closely related. So instead of doing a plus b to the fourth using this traditional binomial theorem, I guess you could say formula right over here, I'm going to calculate it using Pascal's triangle and some of the patterns that we know about the expansion. So once again, let me write down what we're trying to calculate. We're trying to calculate a plus b. So a plus b to the fourth power. To the fourth power. So I'll just do this in a different color. To the fourth power. So what I'm going to do is set up Pascal's triangle. So Pascal's triangle, so we'll start with a 1 at the top. And one way to think about it is, if it's a triangle where if you started up here, at each level you're really counting the different ways that you can get to the different nodes. So 1, and so I'm going to set up a triangle. So if I start here, there's only one way I can get here, and there's only one way that I could get there. But now this third level, there are, if I were to say how many ways can I get here? Well, one way to get here, one way to get here. So there's two ways to get here. One way to get there, one way to get there. The only way I can get there is like that. The only way I could get there is like that. But the way I could get here, I could go like this, or I could go like this. And then we could add a fourth level where, let's see, if I have, there's only one way to go there, but there's 3 ways to go here. 1 plus 2. How are there 3 ways? You could go like this, you could go like this, or you could go like that. Same exact logic. There's 3 ways to get to this point, and then there's only one way to get to that point right over there. And so let's add a 5th level, because this is actually what we care about when we think about something to the 4th power. This is essentially 0th power, binomial to 0th power, 1st power, 2nd power, 3rd power. So let's go to the 4th power. 4th power. So how many ways are there to get here? Well, I just have to go all the way straight down along this left side to get here. So there's only one way. There's 4 ways to get here. I could go like that. I could go like that. I could go like that. And I can go like that. There's 6 ways to go here. 3 ways to get to this place, 3 ways to get to this place. So 6 ways to get to that, and if you have the time, you could figure that out. There's 3 plus 1, 4 ways to get here, and then there's 1 way to get there. And now I'm claiming that these are the coefficients when I'm taking something to the, so this is if I'm taking something to the 0th power. This is if I'm taking a, well, not something, a binomial to the 1st power, to the 2nd power, and you might, obviously a binomial to the 1st power, the coefficients on a and b are just 1 and 1. But when you square it, it would be a squared plus 2ab plus b squared. If you take the 3rd power, these are the coefficients. 3rd power and the 4th power, these are the coefficients. So let's write them down. The coefficients I'm claiming are going to be 1, 4, 6, 4, and 1. And how do I know what the powers of a and b are going to be? Well, I start this first term at the highest power, at a to the 4th, and then I go down from there, a to the 4th, a to the 3rd, a squared, a to the 1st, and I guess I could write a to the 0, a to the 0, which of course is just 1. And then for the 2nd term, I start at the lowest power at 0, and then b to the 1st, b squared, b to the 3rd power, and then b to the 4th, and then I just add those terms together. And I just add those terms together. And there you have it. I have just figured out the expansion of a plus b to the 4th power. A plus b to the 4th power is exactly what I just wrote down. This term right over here, a to the 4th, that's what this term is. 1a to the 4th, b to 0, that's just a to the 4th. This term right over here is equivalent to this term right over there. And so I guess you see that this gave me an equivalent result. Now an interesting question is, why did this work? Why did this work? And I encourage you to pause this video and think about it on your own. Well, to realize why it works, let's just go to these first levels right over here. If I just were to take a plus b to the second power, a plus b, a plus b, a plus b to the second power. This is going to be, we've already seen it, this is going to be a plus b times a plus b. So let me just write that down. A plus b times a plus b. So we have an a, we have a b, and a b. We're going to add these together. And then when you multiply it, you have, so this is going to be equal to a times a. So you get a squared. And that's the only way to get an a squared term. There's only one way of getting an a squared term. Then you're going to have plus a times b. So let me write this. So plus, let me write it this way, plus a times b. And then you're going to have plus this b times that a, so that's going to be another a times b, plus b times b, which is b squared. Now this is interesting right over here. How many ways can you get an a squared term? Well, there's only one way. You're multiplying this a times that a. There's only one way of getting there. Now, how many ways are there of getting the b squared term? How many ways of there getting the b squared term? Well, there's only one way. Multiply this b times this b. There's only one way of getting that. But how many ways are there of getting the ab term? The a to the first, b to the first term. Well, there's two ways. You can multiply this a times that b, or this b times that a. There are, just hit the point home, there are two ways of getting an ab term. And so, when you take the sum of these two, you are left with a squared plus 2 times ab, 2 times ab plus b squared. Notice the exact same coefficients, 1, 2, 1, 1, 2, 1. Why is that like that? Well, there was only one way to get an a squared. There's two ways to get an ab, and there's only one way to get a b squared. If you send it to the third power, you would say, okay, there's only one way to get to a to the third power. You just multiply the first a's all together. And there is only one way to get to b to the third power. But there's three ways to get to a squared b. And you could multiply it out, and we did it. We did it all the way back over here. There's three ways to get a squared b. We saw that right over there. And there are three ways to get ab squared. Three ways to get ab squared. And if you sum this up, you have the expansion of a plus b to the third power. So hopefully you found that interesting.
Okay, so that's where we're going to stop, and that's going to conclude our Khan Academy for today. Know that next time we go in, we'll be doing SAT practice. And it's been proven that students who use Khan Academy for SAT practice for at least 20 hours or more score considerably higher on their SATs than those who do not practice at least 20 hours. Okay, so that's our goal. So if you will log out and close your Chromebooks, and we'll put them up at the end of class. So if you will, actually let's put them up now. Okay, so that's going to take us to our lesson. And so everybody has a Pascal's triangle now worksheet. Make it untangled. All right. So we're going to work with Pascal's triangle and the binomial expansion to work these binomial expansions. So here it says, using Pascal's triangle, what is the expansion of a plus b to the sixth? Use Pascal's triangle. So let's do this. A plus b to the sixth. So start off by writing a plus b to the 6th power. Now what we're going to do, I'm going to show you a little algorithm. Because this is to the 6th power, we know we're going to have, well, this is our n, 6 is our n, and the number of terms that we're going to have is n plus 1. So we're going to end up with 7 terms. Now we're going to use Pascal's triangle, delete this, to calculate this. So what we want to do, we know that we've got a 6, so we're going to go to the 6th row. So go down to the 6th row and look at the numbers on that 6th row. We have 1, 6, 15, 20, 15, 6, and 1. So how many is that? 1, 2, 3, 4, 5, 6, 7. Like I said, we're going to have n plus 1 terms. So we have 7 terms for a binomial to the 6th power expansion. Now we're going to use these terms. Each one of these terms is a coefficient of each one of these terms. And this is how we do it. So every one of these is going to have a coefficient, an a, and a b. Okay? And this is how it works. So we're going to go the first coefficient of 1, a, b, plus the second one, 6, a, b, and we're just setting it up, so we've got a lot more to do, plus 15, a, b, plus 20, a, b, plus 15, a, b, and I'm going to come way down here, let's see, it's 6 and 1, plus 6, a, b, plus 1, a, b. Now, for our a's, we've got to add the powers to our a's and b's. So I'm going to start with my a, and we start with the actual power of 6. So for all my a terms, I'm going to start at 6 and go down. So 5, 4, 3, 2, 1, and 0. Okay? Now for my b's, I'm going to do the opposite. I'm going to start at 0 and I'm going to work my way up. 1, 2, 3, 4, 5, and 6. Okay, is everybody with me? Now, let's clean this up. B to the 0 power is just 1. Anything to the 0 power is just the number 1. So there's an a to the 0 there, that's just 1. Anything to the first power is just itself, right? So you can get rid of that. So now let's clean this up. I'm going to use the pink here. So we don't need that 1 coefficient. So the first term is just a to the 6th times 1, which is just a to the 6th. So that one's simplified now. My second term, I've got 6 a to the 5th b. And now he's done. My third term is just that. There's nothing, just straight copy. 15 a to the 4th b squared. My fourth term, same thing. 20 a cubed b cubed. Same thing here, 15a squared b to the 4th. Oops. It's not liking that. There we go. B to the 4th. And now my next term is going to be 6ab to the 5th plus 1 times 1, which is 1, times b to the 6th. So it's just b to the 6th. So let's just clean this all up for once and for all. It's going to be a to the 6th plus 6a to the 5th b. I'm just rewriting and trying to get it on one line. 15a to the 4th b squared plus 20a cubed b cubed plus 15a squared b to the fourth. Oh, I'm still not going to make it. Plus 6a b to the fifth plus b to the sixth. Oh well, I almost made it. Okay, and that's your answer. Okay, we had it before, but it was just split up on 2 lines. All right, any questions about that? So you look at your power, and then you go to that line on Pascal's triangle, pull out your coefficients, write that with all your ABs, then fix the powers on all of your A's from high to low, and then on your B's from low to high, and then start simplifying. Now, this was pretty easy because we had an A for our first term and a B for our second term. If they're just simple things like that, that's easy. What would happen if they put x plus b? Well, everywhere there was an A, now there should be an x. Okay? So let's take a look at what happens when the coefficients or the binomials get a little more complex. Any questions before I move on? All right. Okay, let's see. 3x minus 2 to the fifth. Let's look at this one. So if I have 3x minus 2 to the fifth power, I no longer have like an a and a b, right? I've got 3x for a, and my b is equal to negative 2. I'm going to put these in parentheses. So what I do, the way I like to do it, you can do whatever method you choose. I like to set it up first as a's and b's. Then after I get that first line that's cleaned up, then I substitute for a and b. So let's do this one. So I've got a fifth power. That means I'm going to have 6 terms, and I'm going to go to the fifth line of my Pascal's triangle. So on my fifth line, I've got 1, 5, 10, 10, 5, 1. Nice and pretty. So let's add these. So I'm going to have a 1ab plus 5ab plus 10ab plus 10ab plus 5ab plus 1ab. Now I'm going to go back and add all my powers. So for a, it's going to start with 5, 4, 3, 2, 1, 0. That's a 0. And for b, I'm going to have a 0, 1, 2, 3, 4, 5. I don't like the way that looks. All right. Any questions so far? Now I'm going to clean it up, because we know b to the 0 is just 1, and 1 times a to the fifth is just a to the fifth, plus b to the first, so it's going to be 5a to the fourth b plus, and that's the same, 10a cubed b squared plus 10a squared b cubed plus 5a to the first power is just 5a, b to the fourth plus 1 times a to the 0, which is just 1, times b to the fifth is just b to the fifth. Now I've cleaned it all up. Now I'm going to substitute 3x for a and negative 2 for b. And the way I like to do this is just write underneath. So if a is 3x, I'm going to write 3x under all my a's. And you don't have to do it this way. Do what works for you. And under all my b's, I'm going to write a -2, and it's going in parentheses because it's got a sign. Okay. Now I'm going to substitute and get a nice pretty answer here. Equation, excuse me. 3x to the 5th power. Everybody see? I just substituted 3x for a, so it's 3x to the 5th. And you must have the parentheses because that's 3 to the 5th times x to the 5th when we expand this in a minute. Okay, plus, and now 5 times a to the 4th, which is 3x to the 4th, and b is -2. So that one's done. Plus, let me switch colors again. I'll go to blue. So this one's going to be 10, 10, and then a cubed, so it's going to be 3x cubed, b squared, so -2 squared, plus 10a squared, which is 3x squared, times b cubed, -2 cubed, and I'm running out of room, so I'm going to go to the next line for the next 2 terms. I'm going to leave some space in there so I can keep working, so I'm going to go down here. So it's going to be 5, let's see, a, which is 3x, times b to the 4th, so -2 to the 4th power, plus -2 to the 5th power. Okay, now we've accounted for everything. It's in 2 lines now, but we can do this. Any questions so far? All right, so now let's do this. This is going to become 3 to the 5th, x to the 5th, plus 5 times 3 to the 4th, x to the 4th, times -2, missed that, plus 10 times 3 cubed x cubed, and -2 squared, let's just go ahead and do that one. That's going to be a 4, plus 10, we can go ahead and do this one. 3 squared x squared is just 9x squared, and -3 squared is -8. And remember, these are all multiplying. Okay, and down here we're going to have 5 times 3x. Well, let's just go ahead and do that one. What's it going to be? 5 times 3x is just 15x. And -2 to the 4th, well, -2 times -2 is +4, times -2 is -8, times -2 is a +16. So we have 15x times +16. And if you want to go ahead and do the math, you know, right now, that's fine. And then a +16 times a -2 would be our -2 to the 5th. So it's going to be a -32. All right. Now keep cleaning up. And at this point, there's so much of it, you might just want to get one of these yellow calculators. And the way you do powers, let's see, that was 3 to the 5th. You type in 3, and then the little symbol that looks like the caret, like we've been doing on the other, it looks like a little rooftop like this. So you do 3 caret 5 for 3 to the 5th power, and press enter, and it tells you it's 243. And then x to the 5th. Okay, so that term's done. And let me delete this right there. All right, and the next one, we've got 5 times, there's -2 times 5. That's going to be a -10 times 3 to the 4th. And 3 to the 4th is going to be 81. So that's going to be -810 x to the 4th. Okay, so that one's done. Plus 3 to the 3rd power times, let's see, we've got 10 times 4, that's going to be 40, times 3 to the third power. 3 times 3 is 9, 9 times 3 is 27. So 27 times 40 is 6. No way is that correct. Is 1080 x cubed plus, we've got 10 times negative 8, that's negative 80 times 9, which is negative 720 x squared. And then 15 times 16 is 240, so 240x minus 32. And now we still have to clean it up. We're still not through cleaning. So now we've got 243x to the 5th. And then minus 810x to the 4th plus 1080x cubed minus 720x squared. I still can't get it on one line. Plus 240x minus 32. And there's my answer on 2 lines. Okay? Any questions over how to do this? A lot of it's just, you didn't even need to see cleaning all that up. But you have to know when you have like 5x to the 3rd power, that's equal to 5 to the 3rd power times x to the 3rd power. Don't forget that, because that's probably the #1 mistake. This is on your exam. All right. So your problems for homework tonight, I'll work the first one with you, but you're going to work problems 1, 3, 5, 7, 16, 20, and 26. And they're all quick and easy. I hand-picked these. So let's do number 1 together. 1, 3, 5, and 7 are simple, single variable expansions. So x plus 4. Look at 3, 5, and 7. 3 is y plus 1, x minus 3, x plus 2. So very simple ones. Then when you get to 16, it's just a question. 20 and 26, state the number of terms in each expansion, and I've been talking about that all day long. How many terms? It's your power, that's n plus 1. So how many terms does 20 have? 4, because it's n plus 1, and n is equal to 3, so it's going to have 4 terms. 1, 2, 3, 4. And you could also just go look at the 3rd row on your Pascal's triangle. There are 1, 2, 3, 4 terms. There's 4 coefficients, so there's 4 terms. And they just want you to calculate the first 2 terms. So that's easy, right? And then 26, you're actually calculating one of the harder ones like we just did. But look at what power I chose, to the 3rd power. So this is easy. Okay, super, super easy. You got this. All right, so let's look at number 1, do it together, and then I'll let you work by yourself. Expand the binomial, and they give us x plus 4 to the 3rd power. So we're going to go to the 3rd row of Pascal's triangle, and we've got 1, 3, 3, 1. So we know our a is equal to x, and our b is equal to 4. Okay, and n is equal to 3. We're going to the 3rd power. So 1, 3, 3, 1. So we're going to go 1ab plus 3ab plus 3ab plus 1ab. Now fix all your powers. It's going to go 3, 2, 1, 0 on my a. And for my b, we're going to go 0, 1, 2, 3. Now a to the 0 is just 1. So that's a 1 times 1. And here's a b to the 0. That's just 1 times 1. All right, so our first term is a cubed plus 3a squared b for our second term plus 3ab squared plus b cubed. All right, so now that we've got our formula here, now just plug in your a and your b. A is equal to x and b is equal to 4. So this is an x, x. And then my b is a 4. So now let's calculate. So it's going to be x cubed plus 3x squared times 4. See, our b is 4. Plus 3, oops, I almost put an a. X 4 squared plus 4 cubed. Well, 4 squared is 16. Let's see, 3 times 4 is 12. So we have x cubed plus 12x squared. 16 times 3 is, let's see, 48. So 48x. And 4 cubed, 4 times 4 is 16 times 4 is going to be 64. So we've got plus 64. And there's your answer. Make sure it's nice and cleaned up before you say that's my final answer. Any questions? Okay, I'll leave this up. I'm going to stop the video now. Do your homework, and this will be due at the beginning of class tomorrow, and we'll move on. So tomorrow we've got a short lesson over, what do we cover tomorrow? 5.8 is polynomial models in the real world. And then we're going to do 5.9, and then that's through. We're through with everything for this semester. Then we've got chapter review, chapter test, and then study guide for the final and the finals. All right, thank you. This concludes our lesson.